Hi everybody, back again. We're going to look at a thermodynamics question for Physics 2. So let's take a look. So this question says to us, 1 mole of an ideal gas undergoes an isobaric expansion. Which of the following graphs of volume as a function of temperature in Kelvin could represent this process? Okay, so isobaric expansion. So let's just write down some of the things they give us. It's ideal gas. Ideal gas. Isobaric. Isobaric means constant pressure. Right? Think about barometric pressure. Constant pressure. So P is not changing. What else? Expansion. So volume is increasing. Volume increase. Okay. Now, let's look at our graphs. From these things so far, since they tell us it's an expansion, volume increase, expansion. If we look at choice C, this volume is staying constant. That doesn't make sense. That's not a good choice. It's out. All right, let's look at these other ones. This graph, they're saying we start down here and we curve up. Yeah, that's an increase in volume. Here, we're starting here, going up. Yep, increase in volume. Here, up, increase in volume. Okay, all of those are increases in volume. Let's think. Now, constant pressure, and I mean the word ideal gas should make you think ideal gas law. So PV equals nRT. And we should probably think about, hey, our y-axis is V, our x-axis is T. If we could rearrange this, normally we're used to seeing lines as y equals mx plus b. Maybe we can use this form to learn a little something about this ideal gas law equation. So let's put V alone by itself, which gives us nR divided by P times T. N is number of moles. It's 1 mole the whole time. No gas is being added or taken away. R is a constant. P, we already said, we are constant pressure. This whole thing is a constant. This coefficient of T is not changing. So this is just like y equals some slope times x, right? Because T is our x and V is our y. So this should be a linear graph. All right, we just eliminated another. Now, if you had a 50-50 guess and you guessed between these two, I'd be pretty happy. There's one more thing that you may or may not have known, and this is kind of one of those things you might need to memorize this. The line of a volume versus temperature graph crosses at 0 Kelvin, there would be no volume. Now, is that realistic? No. That's why they call it an ideal gas, right? It's ideal. It's not a real gas. It's in this ideal world. So, no, it's not actually possible, right? We know that when we get to absolute zero, the molecules that are vibrating around in our gases, they slow down so much at absolute zero, they stop moving. Kind of frozen. Now, that stop motion doesn't mean that they're not taking up any more space, but this ideal gas law actually does assume that this line would cross at 0, 0. Okay? So this is actually not correct, although it is a little bit more realistic in the real world, and that's kind of why I'm saying, you know what? I wouldn't fault you if you got down to these last two and you thought it was that one, right? But this is the correct answer. And the truth is, and they didn't draw this in, I'm drawing it to show it connects to 0. in the choices, there was nothing here. Why is that? Because our ideal gases, as they get colder and colder and colder, at some temperature, they're going to transition. They're going to phase transition into liquids and solids. So they're actually never going to get to this point. The graph is going to change shape as phase changes occur. Okay? So there you go. A little more information about what ideal gases do at 0 degrees Kelvin at absolute zero, and a little more thought about how we can analyze our equations to see what types of graphs they'll give us. All right, see you on the next video. Hope that helped. Take care.